All right, you guys, let's continue our discussion about absolute value inequalities. This time, we're going to look at absolute value inequalities that have the greater than or equal to symbol. Okay, so let's read the formal definition. So it says, if A is a positive number and U is an algebraic expression, then the absolute value of U is greater than A is equivalent to U is less than negative A or U is greater than A. Or we have the absolute value of U is greater than or equal to A is equivalent to U is less than or equal to negative A, or U is greater than or equal to A. So remember I told you guys before that it's important to look at the inequality symbol. So if the inequality symbol that you have is a greater than or equal to, then the way that you're going to fix this expression is by making an or statement, okay? So the way that you do it is that the first statement that you make after you drop the absolute value bars is going to be the exact same one as the one with the absolute value bars, but without them. So you'll see here that the absolute value of U is greater than A is the exact same thing as this second expression, just without the absolute value bars. To make the second expression, you're going to keep whatever was in the absolute value bars the same, but you're going to flip the inequality sign and set it equal to its negative answer, okay? So that's how you will get the two expressions. The first one is exactly the same without the absolute value bars, and the second one flips the inequality symbol and writes the negative answer instead, okay? Now you'll notice when it comes to the answer that it looks like you shade away from the first one and you shade away from the second one. There is not an intersection between the two, okay? So you're always shading on the outside of your answers, okay? These create or compound inequalities, all right? So let's look at an example. So this problem says, solve the inequality, the absolute value of 2x minus 5 is greater than 3, and then graph the solution set, okay? So the first thing I'm going to do is write our problem, okay? Now I'm going to identify the inequality sign. It's a greater than, okay? So I know that my fix is going to be the or statement. So I need to keep that in the back of my head. So before I do anything, I always have to make sure that my absolute value is isolated. It is. So I can drop the absolute value bars, and the first expression is going to be exactly what I have here, but without the absolute value bars. And then I'm going to write or, and then I'm going to write what was in the absolute value bars to start with, but I'm going to flip the inequality sign and write the negative answer. Okay, now I have two inequalities without the absolute value. I can go ahead and solve them like I normally would. So I need to get x by itself. So the first one, I'm going to add 5 to both sides. And then I'm going to divide both sides by 2. So that gives me x is greater than 4. Then for the second one, I'm going to add 5, which gives me 2x is less than 2. And then I'm going to divide by 1, or divide by 2, sorry, which gives me 1. Okay, so my answers is that x is either greater than 4 or x is less than 1. Okay, so just like when we had the absolute value inequalities that had the less than symbols, we're going to go ahead and practice how to write our answers in those 3 different methods. So graphing, set builder notation, and interval notation. Okay, so remember when you're graphing, you're going to draw a number line and you're going to put your 2 answers on there the way that they normally would occur. So 1 is smaller than 4, so it's going to go on the left. Okay, we look at our inequality symbols. Because they are strict inequalities, they're not equal to, we're going to put open circles on our graph. Okay, now this first answer set that we have is that x is greater than 4. So if I'm at 4 and I want the numbers that are bigger than 4, that means I'm going to shade to the right. Okay, and the second solution said we want all of the x's that are less than 1. So if I'm at 1, the numbers that are smaller than 1 are to the left. Okay, so that would be my picture. Now to write it in set builder notation. Remember, in set builder notation, we're going to write our brace, all x, such that, okay? Now, when we write set builder notation, we always want to make sure that we're writing the smallest solutions to the greatest. So that's why it helps to have your picture in front of you, your graph. So this first set on the left-hand side came from the inequality where x is less than 1, and the one on the right came from x is greater than 4. So when we go to write our answer, we're going to write all x such that x is less than 1 or x is greater than 4. Okay. Now in your homework, and especially in My Lab Math, sometimes instead of an or here, they will have a comma in between the two. So they're interchangeable either. Sometimes you can write an or a comma. Okay, so just be careful for that. Now our last type we can write our answer in is an interval notation. So remember, interval notation, I like to think about Mario on our solution set. So he's always starts from the left and moves to the right. So this time, this arrow on the left-hand side is all the way shaded, which tells us that, hey, Mario, everything behind you is safe. So the way that we write that is negative infinity, okay? We're going to write a parentheses. You always put a parentheses around an infinity, okay? And then Mario would walk all the way until he gets to 1, okay? And 1 has an open circle, so we're going to put a parentheses, okay? Now you'll notice that there's a gap in our graph between 1 and 4. That region is not shaded. So if you're thinking about Mario walking, he would have to jump from this set and land on the other one. So we're going to say union, okay? We're joining two sets. And then he would land on 4, okay? 4 has an open circle, so it would get a parentheses, comma. The right-hand arrow is shaded, which lets us know we're going to go all the way to infinity, close parentheses. Okay, so be careful. More than likely, anytime you have an inequality that has a greater than symbol in it, you are going to have an intersection. You're going to have a union. Okay, so for our less thans, we were looking at sets that overlapped. These, you're always joining two sets. They're separated. So the union means you're taking this first set on the left and joining it with the set on the right. Okay, so more than likely, you're always going to have that symbol. Okay, I hope this helps.